Now we're going to practice graphing an ellipse. So the first thing you want to do when you look at the equation, as in example A, you want to first determine whether the ellipse has a major axis that's running vertically or horizontally. In this case, in example A, it's going to be running horizontally because the bigger number is under the term with the x in it. So the major axis will be horizontal. The next thing you want to do is you want to identify your A and B values and your center. In this case, the center is 0, 0, because if you notice, I don't have x minus something or y plus something. It has not been shifted, okay? So my center is going to be 0, 0. So I'll draw that here. That's my center. My A is going to be 5 because A squared is 25. My B is going to be 2 because my B squared is 4. Since I know the major axis runs horizontally, then I know that I'm going to come out 5 in either direction horizontally from the center to find my major vertices. So I'm going to come out 1, 2, 3, 4, 5. Here's one vertice. 1, 2, 3, 4, 5. There's the other vertice. So the length of my major axes is 10, the total length from vertice to vertice. Now, to find my minor vertices, I'm going to go out vertically 2 in either direction. So from the center, I'm going to come out 2 and come out 2. So when I put this all together, here is my ellipse. Now, if in addition I wanted to find my focus point, I would use the formula c squared is equal to a squared minus b squared. So c is going to be the square root of a squared minus b squared. So I'm going to take the square root of 25 minus 4, which is the square root of 21. Now that is the exact value. If we wanted to graph the focus point on the grid, we would have to have a decimal approximation. So when I put that in on my calculator to get a decimal approximation, I'm going to get approximately 4.58. So about 4.5. So my focus point here is going to be here and here. It's going to come out 4.5 in either direction from the center. So my focus points here are going to be pretty close to my vertices along the major axes. Okay. In example B, if you notice, the bigger number is under the term with the y. So in this example, the major axis is going to be vertical. My center is going to be -2, +1 because this has been shifted. And then my value of A is going to be 4 because A squared is 16. My value of B is going to be 3 because B squared is 9. So I'm going to graph my center, which is -2, +1. So here's my center at -2, 1. My major axis is going to be vertical. So when I plot my vertices on the major axes, I have to come out from the center and go up and down a distance of A. So to draw the first vertice from the center, I'm going to come out 4. So 1, 2, 3, 4, that would land me right here at -2, 5. So that's the first major vertice. And then if I go down 4, that's going to bring me to this point here, which is -2, -3. Then to come out along my horizontal axes, which in this case would be my minor axes, I'm going to come out in either direction from the center 3 units. So 1, 2, 3, there's one vertice at 1, 1. And then I'm going to come out 3 from the other direction, 1, 2, 3. There's my other minor vertice, which would be at -5, +1. Then when I put that all together, here is the graph of my ellipse. If I wanted to find my focus points, I would use my formula. C squared is equal to a squared minus b squared, which would give me c is the square root of a squared minus b squared. So I would get the square root of 16 minus 9, which is 7. And if I find a decimal approximation for that, it would be about 2.65. So from the center along the major axes, I would go in either direction, a little over 2, but less than 3 units. So I would come out 1, 2, and 0.65, about right here. That would be the first focus point. And then 1, 2, and then another 0.65, that would be around here. So here's one focus point, here's the other focus point. In this last graphing example, notice that it's not in standard form. So we have to do a little bit of work first to put it in standard form so we can identify all the major features of the graph. So in this equation, I only have an x squared. I don't have an x. So I don't have to complete the square for the x term. But notice I have a y squared and a y here. So I do have to complete the square for the y term in the standard form of the equation. So I'm going to add 3 to both sides. And I'm going to put in a blank here so I can complete the square. I don't have a coefficient in front of the y squared that I have to factor out first, so that saves us a little bit of work. So I can go directly to completing the square. So half of 2 is 1, and then I have to square it to put in a 1 here. 1 squared is 1. And whatever I do to one side, I have to do it to the other side. Now, because I didn't have a coefficient that I had factored out in front of the y squared here, I literally really just put in a 1, so that's all I have to do on the other side. So now I have y squared plus 2y plus 1 is equal to 4. So I can factor this into a perfect square now. Y squared plus 2y plus 1. If I factor that, that's going to be y plus 1 times y plus 1. So I can rewrite this as y plus 1 squared. Now I have to divide everything by 4 so I get a 1 on the right-hand side. So when I divide this by 4, this by 4, and this by 4, I get x squared over 1 plus y plus 1 squared over 4 is equal to 1. If you notice, the bigger of the two numbers down here, it's under the y term, so that means this is going to have a major axis that is vertical. My a is going to be 2 because my a squared is 4. My b is going to be 1 because b squared is 1. Then to find my c, I'm going to use the formula c squared is equal to a squared minus b squared. And what I'm going to get is the square root of 3, which is approximately 1.7. My center, if you notice, since my horizontal term doesn't have a shift, my value of h is 0. But I am shifted on this one vertically, so my center is going to be 0, -1. So this is going to be my center right here at 0, -1. Now, since my major axis is vertical, to find my major vertices, and because my A is 2, I'm going to come out 2 units in either direction up and down from my center. So here is one major vertice at 0, 1, and here's the other major vertice at 0, -3. Now for my minor vertices, I'm going to come out horizontally in either direction from the center. And that's going to be a distance of 1 in either direction. So here and here. So my minor vertice is going to be at 1, -1, and the other minor vertice is going to be at -1, -1. When I put that all together, here's my ellipse. And then if I want to graph my foci, I'm going to come out approximately 1.7, so less than 2 in either direction up and down on my major axes from my center. So my focus would be about here, and the other focus would be about here. So those are going to be pretty close to the major vertices on either end.